Think about almost anything you own, your phone, your car, even your coffee maker. Chances are, it was built by a small army of machines that all have to talk to each other with perfect, split-second timing. But how on earth do they do it? Well, today, we're diving into the hidden nervous system of the modern factory, the industrial networks that make it all possible. So picture this, a massive automated factory floor. You've got hundreds of robots, sensors, motors, and controllers all needing to work in perfect harmony, down to the microsecond. How do they pull it off? The secret is a fascinating world of specialized communication protocols, basically the languages that these machines use to talk to each other.
All right, so to really get where we are today, we've got to rewind the clock a bit. We need to look at where this all started, with the foundational protocols, the original reliable workhorses that really laid the groundwork for everything that came after.
And one of the biggest names back in the day was a system called Data Highway Plus, or just DH Plus. Its entire purpose was to create a single, orderly conversation on the factory floor, to stop the chaos of every device trying to shout over each other all at once.
So how did it keep things so orderly? Well, it used this really clever method called token passing. The best way to think about it is like a meeting with a talking stick. A digital token, the talking stick, gets passed from machine to machine. You can only speak or send data when you're holding the token. It's a simple rule, but it absolutely guaranteed that communications were predictable and collision-free.
This was the world that those classic programmable logic controllers, the industrial computers like the legendary PLC-5, lived in. It had its limits, of course. You could only connect up to 64 devices. And it was famous for this thick, shielded cable that everybody in the industry just called the blue hose. I mean, you could spot it from a mile away. It was tough as nails and super reliable.
And what about speed? Well, it topped out at about 230 kilobits per second. Now, I know what you're thinking, that sounds incredibly slow today, right? But for sending critical data reliably across a noisy factory floor back then, it was a total game changer. Just, keep that number in your head because we are about to see it get completely obliterated.
Because, just like the rest of the world, the factory floor was about to be turned upside down by a technology that we all use every single day, Ethernet. That old private country road was about to become a data superhighway.
The protocol that really brought Ethernet to the factory, Ethernet IP, was just a massive leap forward. Look at these numbers. The speed jumped from kilobits to gigabits. We're talking thousands of times faster. The 64 device limit? Poof, gone. Practically unlimited now. But honestly, the biggest change was the cost. That expensive proprietary blue hose got replaced by the same standard off-the-shelf Ethernet cables you'd find in any office. This didn't just make factories faster, it made modern automation affordable and accessible for pretty much everyone.
So when you boil it all down, Ethernet/IP became the new default for most automation because it was built on a standard everyone already knew and used. It was cheap, it was incredibly scalable, and it was flexible enough to support all these modern layouts and, crucially, modern security features. Things the old guard just couldn't handle. But here's the thing. Not every job on the factory floor is what you'd call general purpose. Some applications, especially things like high-speed robotics or perfectly coordinated motion control, need more than just raw speed. They need absolute, unwavering, deterministic precision. And this created a need for a whole new class of high-performance specialists. And when we talk about these specialists, one of the biggest names you're going to hear is EtherCAT. It was designed from the ground up for basically one thing: absolutely blistering speed and near-perfect synchronization for the most demanding control tasks you can possibly imagine. So what's its secret sauce? It's this brilliant concept called processing on the fly. Okay, think of a normal network like a mail truck that has to stop at every single house to drop off and pick up mail. Now, forget that. EtherCAT is a bullet train. The data frame, the train, never stops. As it blasts through each device, that device instantly plucks its own data out and shoves new data back in, all without ever slowing the train down. Let's walk through it. The master controller sends out a single frame. It zips through the first device, which reads and writes its data in hardware, literally on the fly. That same frame keeps going to the next device, and the next, without ever being stopped or repackaged. It makes a full loop and gets back to the master, all in a matter of microseconds. This is efficiency on a completely different level. So you might be thinking, wait, it has Ether in the name. Isn't it just another type of Ethernet? Well, not really. Here's the key difference. Ethernet/IP is for general data, where a millisecond of delay here or there doesn't really matter.
EtherCAT is for extreme real-time control, where even the tiniest little timing variation, what we call jitter, can cause a huge problem. Its timing is so precise, its jitter is measured in nanoseconds. It's a pure specialist that just happens to borrow Ethernet's physical hardware to do its job.
But EtherCAT isn't the only game in town when it comes to this high-speed world. Another major player is SERCOS, and it also has a really long history, starting out with early versions that actually used fiber optic cables for incredible amenity to electrical noise, before it eventually evolved into SERCOS 3, which, like its competitors, also started using standard Ethernet hardware.
Now, SERCOS gets to that same level of precision, but it does it in a totally different way. If EtherCAT is a bullet train, SERCOS is more like a perfectly scheduled airport. The whole network cycle is divided into these super precise time slots, and each device gets its own exclusive window to land its data. This completely guarantees there are zero collisions and that all the critical information arrives exactly when it's supposed to, every single time.
Okay, so we've gone on quite a journey, right? From the old guard to the Ethernet superhighway and then to these high-performance specialists. And what this whole evolution really shows us is that industrial networking isn't about one protocol beating another. It's about building a complete and versatile toolbox.
And this chart really breaks it all down. Think of it as a little cheat sheet. If you've got an old but still reliable machine you need to talk to, you're probably still going to use a legacy protocol like DH+. For the general backbone of the factory, the cheap and scalable Ethernet IP is almost always the right choice. But for that brand new, high-speed robotic cell that needs perfect timing, that's when you reach for a specialist tool like EtherCAT or SERCOS. See? Each one has its perfect job.
So the main thing to take away from all this is simple. There is no single best network. There just isn't. The goal isn't to find one winner to rule them all. The real skill is in understanding the specific job that needs to be done and then picking the exact right tool from the toolbox for that application.
And that leaves us with a really fascinating question for the future, right? We've seen this incredible leap from proprietary cables to standard Ethernet. So as factories get even smarter, as they connect to the cloud and start using AI to make decisions, what new demands is that going to put on these networks? What is the next great leap in industrial communication going to look like? That's definitely something to think about. Thanks for digging into this with me.